Okay, let's get started looking at the simple descriptive statistics of our dataset. We acknowledge that you might not have a statistics background, so we will focus on a very lightweight overview of these functions. Your next class on statistics in this MicroMasters program will provide you with the right background to do more with the statistical operations in pandas. Let's focus now on the rating column stored in the ratings data frame for the rest of this video. As you might remember, we explored with this data set, and ratings are in a data frame called ratings. Just like you see here, the top 5 rows or indices in that data frame. So let's go back to the descriptive statistics part of our notebook. We will first describe the values in this column using the describe function. Remember, describe function will give us some statistics over those. And we see that that part is running, and we get a count, mean, standard deviation, and all of those here. A count of the defined or useful values in this column shows that there are more than 2 million ratings recorded with a mean of 3.53, or I rounded that to 3.53. Standard deviation is a measure of spread or variability in your data. A smaller deviation is good when it comes to errors. However, if your data naturally contains a lot of variability, it is a property of your observation about that data. So if we then have the percentiles, if 50% is 3.5, that means more than half of the ratings are 3.5 or less. Similarly here, 75 of the ratings are below 4.0, and that's sort of given in that 75 percentile column, sorry, row. Note that we could have provided the whole data frame to describe. Here we just provided the ratings, but I can copy and paste this quickly. And instead of ratings rating, I'll describe the whole data frame. Although this is often very useful, in our dataset, user ID and movie ID are columns that only store identifiers rather than measurements. So we can safely leave their statistics out. That's why we opted to choose only the ratings column. Next, I'll calculate the mean of ratings, just like we've done with the describe. But in this case, it's only going to give us that mean value. So if you're only interested in knowing the mean, just like you would see here for that rating column, you would call the mean function rather than calling this whole-blown this describe function. We could have done the mean again across global data frame. So if we've done that, we would have the mean of each column as a row, or in this table, user ID mean, movie ID mean, and ratings mean, just like these 3 values would be printed one after the other. Okay, next we will look at the value of the ratings, minimum and maximum ratings shortly. Let's run these two. We are saying ratings, and we are selecting from the ratings that rating column, and we say dot min. I'll run the minimum and maximum. Okay, minimum is 0.5 and maximum is 5.0. So they are both in the range of possible good values. So the rating should be between 0 and 5, and we see minimum and maximum are within that range. We can now use a standard deviation between ratings. That's, again, as a reminder, how spread out they are from the average. So it gives us the measure of the variability or the variance in these ratings. So we'll just use the standard deviation function. Knowing the most frequent rating value might also be interesting. The mode function will give us this information. So let's run the mode function on that ratings column. It counts every value and finds the most frequent one. So in this case, 4.0 is the most frequent rating. So movies were rated at 4.0 most of the time. At this point, I would normally look at the correlation between columns with measurable variables. In our data set, since we only have one column of this type, the rating, running the correlation function over the data frame won't give us much information, unfortunately. But let's do it just to show how correlation function formats its output. So here we just say over the whole data frame, ratings.corr for correlation. And if you run that, you'll see that we have a table with rows and columns with the column labels in our data frame. So those are ideally each measurable variables. And the table shows the correlation score of each variable against another. So as you would remember, a negative correlation score here means those features in our data sets are inversely correlated. So one goes up, one goes down. And increase in one means a decrease in other in that sense. However, as I mentioned before, we won't take this result into consideration for analysis, as we know these variables can't be related. So that also shows you, to understand correlations, we really need to have more domain information. As we go along in other notebooks, we will be able to see the correlation scores with more conclusive outcomes, I hope. In the next line, I will check if there is any rating above 0. So we can do a global logical comparison over the whole column, resulting in a series object with Boolean values for each row of our data frame. So we can do that by saying, select the ratings from rating and compare it if it's larger or greater than 5. And it's going to give us that series object with Boolean values in it. So if a value is greater than 5, it's going to have true in that row. If a value in a row in that rating column is less than 5, we're going to have a false. So let's run this. Filter.any here will tell us if any of those values in that filter1 series is true. In this case, we get the false as output because there's no rating in this data set that's more than or greater than 5. So just to have an understanding of how that filter looks like, let's print the series object, filter1. I can actually first print the type of it, so we know that it's a series object. Let's get rid of this any for a sec. And we know it's a series object. Right? So let's move back, and instead of the type, let's print the filter object. So when I do that, we see that that object, or that series object, is a column that compares that rating to 5, and we go from 0, false, 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 to something that spans all the rows, right? We have about 2 million rows here, or more than that, and they're all false. So that's our ratings in the data, in the ratings database. And from the little of it we see that there are indeed no true values. We could have also done the opposite using the all function. If we are checking if all of the values in that column is true. A condition that requires us to do would be we want to make sure all of the values, all of the rating values are above 0. And we already looked at the minimum. We know that's the case. So we'll run a condition here, ratings.rating greater than 0. And the resulting series object will assign to filter 2. And then we'll check all of the values in that filter 2 Boolean series is true. So let's quickly run this, and we'll get true as a response. Okay, now we explored with some statistics on the data set. Let's move on to data cleaning. And we'll first review the data cleaning functions in pandas for that.